Jai Hind students, welcome to my YouTube channel. Students, with every experiment you conduct, you learn a tremendous amount about yourself, about other people, and about the world around you. Moreover, you learn about what works and what doesn't work, and can therefore make appropriate and necessary adjustments moving forward. That positive note, students, let's begin this session. In this particular session, what we are going to do is, we are going to discuss a very interesting and important experiment. And in this experiment, we are supposed to determine the angle of minimum deviation for a given glass prism. And for that, we will plot a graph between the angle of incidence and the angle of deviation. And then, students, we are also supposed to determine the value of refractive index of the material of the prism. And these are the things which we will be requiring so as to perform this particular experiment. Now students, in order to find out the refractive index of the material of the prism, we need to have a working formula. So, the refractive index of the material of a prism, it is given by so the formula is mu is equal to, this is the refractive index, it is equal to sine A plus del m by 2. Now students, here A is the angle of prism and del m, it is the angle of minimum deviation, right? At the position of minimum deviation, angle of incidence is equal to angle of emergence. Then you are aware the refracted ray, it becomes parallel to the base of the prism, and R1 is also equal to R2, right? What I mean to say is that at del equals to del m, the prism under consideration, it is placed symmetrically with respect to the incident ray as well as the emergent ray. So the formula is mu is equal to sine A plus del m by 2 divided by sine A by 2. This is the working formula. So first and foremost, we will plot a graph between the angle of incidence and the angle of deviation, and from that graph we will try to evaluate the formula of del m. Now substituting the value of del m and knowing the value of A, which is for an equilateral prism, we will consider the value of A to be 60 degree. It can be easily measured. So knowing the value of A and del m, the value of refractive index of the material of the prism can be easily found. Students, let us watch the video so as to understand the procedure as well as the method so as to draw the ray diagram, so that we can plot a graph between different values of angle of incidence and the angle of deviation. The objective of this experiment is to determine the angle of minimum deviation, and also we will try to determine the value of refractive index of the material of this given prism. A prism is actually the portion of transparent refracting medium that is bound by two plane surfaces which meet each other along a straight edge. The two plane surfaces are called refracting faces. And students, in order to perform this particular experiment, we will be requiring a glass prism, a drawing board, a sheet of paper, drawing pins or paper pins, a protractor and a scale. Initially, we will fix a sheet of paper on the drawing board with the help of drawing pins, and then we will draw a line in the middle of the paper and place the prism such that its face is parallel to the drawn line. Now students, we will draw its boundary with the help of a sharp pencil. Now after removing the prism, we will draw a normal roughly at the center of the refracting face. Now students, normal is an imagined line drawn perpendicular to the surface. Now using a protractor, we will draw a line which is making an angle of 35 degree with the normal. Now this line will act as the incident ray, and the angle which this incident ray makes with the normal, that is the angle of incidence. Now we need to fix two pins on the incident ray, and it is to be ensured that the pins are fixed vertical and with a minimum separation of 8 to 10 centimeters. And thereafter we will put the prism back in its position and then look for the images of the pins P and Q through the refracting phase. Students, the images of the two pins which are fixed on the incident ray can be easily seen through the second refracting phase of the prism. Now, we need to bring the images of these two pins in a line, and we need to fix a third pin so that all the three pins lie on the same straight line. I repeat, students, we need to fix a third pin so that it is in line with the images of the earlier two pins. Now it's perfect. So now you can check all the three pins are lying in the same straight line. Now students, after this, we need to bring the images of the two pins on the incident ray with the fourth pin so that it is also in line with the other three pins. This is perfect. So all the four pins must lie on the same straight line. This is the most important aspect of this particular experiment. So it needs patience, and you need to laterally shift your eye and check. There can be only one unique position where all the four pins lie on the same straight line. After this, students, we need to remove this prism, and then we also need to remove the pins one by one. After that, students, we need to encircle the positions of the fourth pin. Then similarly, we need to encircle the position of the third pin, and then the positions of the pins on the incident ray. Now students, what to do is, we need to draw a line joining the positions of the third and the fourth pin. So this is the line. This will represent the emergent ray. Don't forget to indicate the arrow. Now students, we need to draw a normal at this particular point. Normal is an imaginary line which is perpendicular to the surface. Now let us produce the incident ray. Now students, in the absence of the prism, the incident ray would have travelled along this straight line as per the rectilinear propagation of the light. Also, let's produce the emergent ray in the backward direction. The angle which the incident ray when produced makes with the emergent ray, that is the angle of deviation. So this is the angle of deviation which I am representing by del. Angle which this emergent ray makes with the normal, that is what we call as the angle of emergence. We will represent it by small letter e. This is the angle of emergence. Now let's make use of this d so as to measure the angle of deviation and the angle of emergence. So angle of deviation, this angle, as you can see students, it is about 44 degree, right? Angle of deviation, it comes out to be about 44 degree. So del is equal to 44 degree. Now let's find out the angle of emergence. As I've stated, it is the angle which the emergent ray makes with the normal. This is the normal. This is 90 degree. So it is this angle which we need to measure with the help of this protector. So this angle comes out to be, look, it is 69 degree, right? This is 10, 20, 30, 40, 50, 60 and this is 69 degree. So angle of emergence corresponding to the angle of incidence of 35 degree comes out to be 69 degree. And students, this is the angle of prism. This is the first refracting phase. This one is the second refracting phase. The angle between these two refracting phases, that's the angle of prism. And for an equilateral prism, the angle of prism is 60 degree. And this would be the base of the prism. This is the base of the prism. Yes, students, in this sheet, I have drawn 3 ray diagrams, right, for different angles of incidence. This is for angle of incidence of 35 degree. This one is for angle of incidence of 40 degree. And this ray diagram is corresponding to angle of incidence of 45 degree. Now, students, here it is observed that corresponding to I equals to 35 degree, the angle of deviation, it is found to be 44 degree. Corresponding to I equals to 40 degree, the angle of deviation is found to be 40 degree, right? This is the angle of deviation, which is the angle the emergent ray makes with the incident ray when produced. And over here, students, corresponding to angle of incidence of 45 degree, we have obtained the angle of deviation to be 38.5 degree. So this is the angle I am talking about. Also, students, in all the cases, I have also measured the angle of emergence. Angle of emergence is the angle which this emergent ray makes with the normal. So here the angle of emergence is measured to be 69 degree. Here it is 60 degree. Corresponding to angle of incidence of 45 degree, the angle of emergence is obtained to be 53.5 degree. And the prism which I have used is an equilateral prism. So A being the angle of prism, it is 60 degree. So here I have written the values for each and every experiment, right? So let's find out the value of A plus del over here. A is 60, del is 44. So A plus del is 104 degree. I plus E. I is 35 and E is 69. So again I plus E also comes out to be 104 degree. So students, what do you conclude? A plus del is equal to I plus E. Let's verify this formula for this particular set of observations, right? Here A is 60 degree, del is 40 degree. So A plus del, 60 plus 40, it would be 100 degree. Over here I plus E, 40 plus 60, again it comes out to be 100 degree. So this relationship between angle of prism, angle of deviation, angle of incidence and the angle of emergence is found to same, right? A plus del, it's found to be equal to I plus E. Let's consider for this third set of observation. A is 60, del is 38.5. So A plus del, it would be 98.5 degree. Now let's see the value of I plus E. I is 45 and E is 53.5. So it again comes out to be 98.5 degree. So students, it's verified for any angle of incidence for a given prism, this formula which is A plus del is equal to I plus E, that stands valid. This is another sheet, students. Here this is the ray diagram corresponding to angle of incidence of 50 degree. This is the fifth set of observation corresponding to angle of incidence of 55 degree. And this is the sixth set of observation corresponding to the angle of incidence of 60 degree. Now, this is the angle of deviation. I'll represent it with red ink. So this is the angle of deviation. It is the angle which the emergent ray makes with the incident ray when produced, right? And this is the angle of emergence. This is the emergent ray and the angle which it makes with the normal. So Always remember students, the angle is to be measured with respect to the normal. So that's the angle of emergence. I'm representing it with blue ink. Okay, now let's verify the formula for these three set of observations. Here I've written the values. So let's find out A plus del. 60 plus 38, it will give us 98, right? I plus E, 50 plus 48, again it will give us 98. So A plus del is equal to I plus E. Also over here, 60 plus 38.5, so it comes out to be 98.5 degree. Now I plus E, that is 55 plus 43.5, so it is again 98.5 degree. So students, as you can see, for any angle of incidence, the sum of the angle of prism and the angle of deviation is always equal to the sum of the angle of incidence and the angle of emergence. Let's verify it for the sixth set of observation. So A plus del over here, it would be 99.5. I plus E also is equal to 60 plus 39.5. So it will be also 99.5. So for the sixth set of observation also, this formula holds valid. Right? I must state that one more relationship can be verified, which is A is equal to R1 plus R2. Now look students, this is the incident ray, this is the refracted ray, and this is the emergent ray, right? This is the angle of refraction at this point. This is R1, right? It is the angle which the refracted ray makes with the normal. And this angle, students, this one is R2. So, it's left as an exercise for you. You can measure angle R1 and R2 and then verify the fact that A is equal to R1 plus R2. Here also, this angle is R1. This angle will be R2, and you can verify that angle of prism, it's equal to R1 plus R2. For any angle of incidence, this is the formula which will be valid. This is R1 and this small angle is R2. So angle of prism is always equal to R1 plus R2. So students, this is the observation table which we have obtained, right? So this is the column for angle of incidence in degrees, and this is the corresponding values of angle of deviation again in degrees. Now here we need to plot a graph between the angle of incidence and the angle of deviation. Angle of incidence is represented along the horizontal axis, while the angle of deviation is represented along the vertical axis. Okay, let's plot the first point, 35 degree and 44. 35 is the angle of incidence and 44 degree is the angle of deviation. So this is 44 degree. So this is the point, 35 degree and 44 degree. Okay, next point is 40 degree and 40 degree. This is 40 and this is 40. So this is the point, right? This is the point, 40 and 40. Next one is 45 degree and 38.5. 45 degree and this is 38.5. So this is the point I'm talking about. So the points are 45 and 38.5 degree. Okay, fourth observation is corresponding to angle of incidence of 50 degree, we have angle of deviation of 38 degree. So corresponding to 50 degree, we have got the angle of deviation as 38 degree, this point. So it is 50 and 38. Now the fifth observation is 55 degree and 38.5 degree. 55 degree and 38.5 degree, this one. Between 38 and 39, this is 38.5. So this is 55 degree and 38.5 degree, right? And the last one is corresponding to angle of incidence of 60 degree. We have the angle of deviation of 39.5 degree. Corresponding to 60 degree, we have 39.5 degree. So this is the point. So 60 degree and then 39.5 degree. Now students, what we need to do is that we need to join these points and draw a freehand curve, right? The graph obtained is as shown over here, right? So what we conclude from this graph, students? Initially, as we can check, with the increase in the angle of incidence, the angular deviation decreases. Then corresponding to a particular angle of incidence, the angular deviation attains a minimum value. And thereafter still the angle of incidence is increased, the angular deviation starts increasing. So this is the nature of the graph, right? Also students, this is the point, the lowermost point, and corresponding to this point the angular deviation is minimum. So let's determine the angle of deviation from this graph. So this is it. So it comes out to be about over here. So it is 37, 37.5, 37.6, 37.7 and this is 37.8. So with the help of this graph, we can easily determine the value of angle of minimum deviation. So what we obtained is del m. It is equal to 37.8 degree, right? This is the value of minimum deviation angle. Now students, one more thing to be noted is that corresponding to del m, that is corresponding to minimum deviation angle, there can be only one unique value of angle of incidence. But students, there can be two different angle of incidences corresponding to the same angle of deviation. Here you can check. Angular deviation is 38.5 degree. Here also it is 38.5 degree. So corresponding to angle of incidence of 45 degree and angle of incidence of 55 degree, we have got the same angle of deviation. So students, again I repeat, there can be two different values of angle of incidences for a given value of angle of deviation. But corresponding to del m, which is the minimum deviation angle, there can be only one unique value of angle of incidence, right? So now students, we need to determine the value of refractive index of the material of the prism. And as we have discussed earlier, the working formula, or rather the formula for the refractive index, it is sine A plus del m by 2. A is the angle of prism, which we have considered to be an equilateral prism. So A would be 60 degree, divided by sine A by 2. I will share the link of my video concerning the theoretical lecture of this particular topic, right, in the description box. So you can refer to that as well for the mathematical derivation of this particular formula. Now students, we need to substitute this value of A and del m, and we can easily obtain the value of refractive index. Now students, after successfully completing this experiment, these are the results which we have obtained, right? First and foremost, we have proved that for any angle of incidence, the sum of the angle of prism and the angle of deviation is always equal to the sum of the angle of incidence and the angle of emergence, right? Second is, student, this formula can also be verified that the angle of prism is always equal to R1 plus R2. Third is, students, with the help of the graph which we have plotted between the angle of incidence and the angle of deviation, we have determined the value of minimum deviation angle, and the value of del m is found to be 37.8 degree. And last but not the least, using this formula over here and substituting the value of A and del m, we have determined the value of refractive index of the material of the prism, which is found to be about 1.5. To be precise, it is found to be 1.507. So these are the four results which we have found using this particular experiment, right? So students, that's it. Let's conclude this particular session and keep watching my videos for new experiments and new theoretical explanations. Thank you.